lectures uh, and has been regularly organizing and in the honor of the eminent engineers like Engineer V. Subbarao, Dr. J. Purushottam, Engineer Koka Krishnamohan, Engineer T. Hanmantarao, Engineer J. V. Subbarao, Engineer A. P. Ranganatha Swami, and Dr. S. Raghavachari, and Dr. Narla Tatarao, and Engineer Matur Gopal Rao, and Engineer Atluri Venkateshwar Rao, and Engineer Gurram Reddy, and Engineer R.L. Raju, Dr. John A. Murray, and Engineers Venkata Krishna Iyer, K.V. Srinivas Rao, and M.L. Swami, and Dr. A. Ramakrishna, and Engineer I. Basavaraju, Endowment lectures. And I take this opportunity to say a few words about our legendary engineer, late engineer R.L. Raju. Engineer R.L. Raju obtained BE from Civil in the Gundi Engineering College from the Madras University in 1947. After completion of engineering, he joined the same college and continued till the December 1949. After he joined as assistant engineer in the irrigation department, government of the Madras in 1956, he was elevated to the post of executive engineer posted in the Nagarjuna Sagar project to investigate and execute Nagarjuna Sagar Right Canal. In the year 1960, he was posted as a deputy chief engineer for Nagarjuna Sagar Right Canal, and in the year 1964, he was promoted and posted as superintending engineer, Godavari Valley Circle, to execute Pochampadu project, now named as the Sri Ram Sagar project. And after serving various positions, Engineer R.L. Raju was shifted to Godavari Barrage Design Circle in Chief Engineer's office at Erramanjal. After that, he moved from Godavari Barrage Circle to the Vijayawada Irrigation Circle for a short time, and he was promoted as Chief Engineer in April 1974 and posted as Chief Engineer, Sri Salem Hydroelectrical Project, and finally he retired in the July 1978 from the Irrigation Department. And Engineer R.L. Raju passed away on 4th May 2017. And it's a sad moment that such a great man, great engineers, so many great engineers we have been celebrating in the memory of their work they have done and contributed to the nation. So I know, and today we have arranged a talk, uh, and the speaker is Dr. I.S. Rajagaru, who is an eminent expert in the subject matter. And also, I welcome again the respected speaker, Dr. I.S. Rajagaru, and all of you to this important event. And thanks one and all. Now, I request Engineer T. Venkatesham to kindly introduce the speaker and over to Engineer T. Venkatesham Garu.
Sir, Venkatesham sir is not available. I will introduce sir.
Can you introduce, sir?
Yes, sir. I am very happy to introduce Dr. I. Satyanarayan Raju Garu. So Dr. I. Satyanarayan Raju did graduation in civil engineering and post-graduation in structural engineering in first class with distinction, and also PhD from JNTU, Hyderabad. He served in irrigation department of government of erstwhile Andhra Pradesh for 35 years in various capacities and retired as chief engineer in 2011, and also held positions as director APERL DZ Kalantari at Hyderabad. He was the recipient of Best Irrigation Engineer Award in the year 2003 by Government of erstwhile AP and IEI APSC and many merit awards including Best State Level Nodal Officer of Government of AP Programs in the year 1996 while in service. He presented over 40 technical papers in Institution of Engineers India, such as seminars, workshops, and other different fora. He served as chairman of AP and Telangana State Center at Hyderabad during 2014 to 16, and also National Council member of IEI during 2012 to 2016. Presently, Dr. I. Satyanarayan Raju, FYE, is rendering services as a technical consultant to NABARD, AP and Telangana, and serving freelancer, technical consultant come expert, arbitrator, and adjudicator. He also elected as a National Council member of IEI for the sessions 2021 to 25 and the chairman of Research and Development Cell of Institution of Engineers. So with this, I request Dr. ISN Raju Garu, FYE, to start his lecture. Sir, please, sir.
Good evening to all of you, and our chairman, respected chairman, Dr. Brahma Reddy Garu, and our honorary secretary who has introduced me on this occasion, Dr. G. Venkat Subbaya Garu, and esteemed colleagues, corporate members, council members, and also the Telangana State Committee members and other allied gathering for this occasion. And before proceeding to the presentation, I would say a few words about Engineer R.L. Raju Garu. So it is my privilege that when I was the chairman of Institute of Engineers AP State Center, and in his last days, R.L. Raju Garu and his daughter came to our institute, and his daughter expressed a desire that they want to institute a endowment lecture. At that time, our Prabhakar sir is also there. You all know him as a very senior engineer of irrigation department. So we immediately spontaneously responded and instituted the first endowment lecture, and first endowment lecture was also conducted there. And about R.L. Raju Garu, so already our Brahma Reddy Garu told about his greatness. I think I was very junior in the department when he was the chief engineer of Srisailam Dam, and we are very much motivated by his service in the irrigation department. Everybody says that he is a highly honest officer and very dedicated and sincere officer, and he never budged an inch for any pressure, and he never gone to the line of politicians also. One incident everybody used to tell that when he was a superintendent irrigation circle in Vijayawada, when one of the minister for irrigation asked to do certain things which is beyond the rule position, he has not done it. So keeping that vengeance, that politician come minister, honorable minister for irrigation, suspended him, but immediately, so the then chief minister, Jalaga Rao Garu, so he has reinstated. He was reinstated knowing his background and his uprightness and his technical knowledge. That is only one incident which speaks high about R.L. Raju Garu. He is very meticulous in timings, and also, so whenever he gives a time to reach office, when he is returning from any camp, if 10 minutes time is there, you have to stop and just enter the stroke of the hour to the office also. And he was very, very meticulous in designs and also. So nowadays, for some time he was a design superintendent engineer in Naramanjal at that time. There is no CDO. At that time also, when designs also, that he is meticulous, that he has used to keep that factor of safety or anything tolerance also within the permissible limits. That is his sincere and dedication. With these few words and great respects to R.L. Raju Garu. So he is our chief engineer of irrigation department of yesteryear's generation. And just now, because the general secretary, honorary secretary, and president were on the moving, so I got an opportunity to garland his photo and lighting the lamp as a remark of the commencement of this one. So paying respect to him. So with these few words, let us go into the presentation. It's a very, very important presentation, that is geosynthetics, use of application of geosynthetics in irrigation projects. So when we'll go into the presentation, we'll know about what exactly geosynthetics, how it is useful, and all the things we can discuss. So geosynthetics is a polymer material. So it is so improve the soil or rock or geotechnical material. So because we can construct any structure on existing soil. If soil is a poor soil, so then the size of the structure and the cost of structure will get increased. increased. But using geosynthetics, we can stabilize the soil, improve the properties and the bearing capacities also. We can economize, and it is an alternative to these materials. I think natural resources like soil, sand, or even the metal and other things also. That is a very important thing. And it is a polymer material. So that was this one else. So there are different forms of geosynthetics also. That is also geotextile. That is in a sheet of water. Textile means you are just like resembles a textile of our natural what we are wearing. It is a geotextile. That is one layer will be there. So it is a family of geosynthetic family. It is a permeable, polymeric and natural fiber textile, maybe woven or geotextile, non-woven. I will show you the difference between woven and non-woven also. Geo grid. So just grid is nothing but in our RCC slabs also will have a reinforcement in both ways. It looks like a grid. Similarly, the geo grids also can be used to improve the strength of the foundations or improve the bearing capacities and other things also. And geocell, it is a cellular structure consisting of a regular open network of synthetic strips linked by extrusion, adhesion, used to geotechnical, environmental, hydraulic, and transport engineering. Geomembrane is a very low permeability synthetic membrane liner and a barrier used with geotechnical engineering. That is geomembrane also is used for to limit the CPS loss and other loss also. So just like a geotextile, there is a biotextile is also there that comes from the same family of geosynthetics. It is a permeable textile material made by biodegradable natural fibers. Best example is our banana fibers also. Banana stem fiber also we can use by giving some treatment also that comes under, and it can be drawn into sheet also, and biocells also that like that. Even coconut fiber is also, it comes under this biotextile also. These are some of the examples of these funnels. So actually now we are discussing about sustainable development. So sustainable development, geosynthetics plays a major role in sustainable development because it reduces or economizes the existing natural resources for construction engineering. The construction, that materials are natural, that materials are about sand, soil, and also the metal and other things are also. So it will economize or it replace to some extent. So because all the natural resources, what I spoken about civil engineering construction material is, they are not renewable. They are all, if you go on exhausting that material at one time, there will be shortage. I think geosynthetics will replace that and makes the sustainability of these materials also. It will improve the geological material behavioral, that is a soil or sand, or also to the extent of metal and other things also. And geosynthetics are that they are developed, synthesized for specific function or application construction. Different forms are there, different functions are there. In the next slide, we are going to discuss about different functions of this geosynthetics. And as of now, across I think in India, we started lately using this geosynthetics, but this geosynthetics is being used globally for the last 5 decades. So as of now, nearly 1 billion square meters of geosynthetics is being used annually in civil engineering construction across the globe. So about the composition and varieties. So actually the composition of geosynthetics is polypropylene, high density polyethylene film, and polyester, PVC, synthetic rubber, and sometimes use these natural fibers of jute and coir also. As already I discussed, different forms of these synthetics are geotextiles, and they are woven and non-woven. Geo grids also, I will show you the figures also. Geomembranes, geocomposites. Geocomposites means making a product of using 2-3 geosynthetic, the different forms of geosynthetics. Geocomposite, geo nets are also there, geofibers are all there. So geofibers is best example is fiber concrete also. We can use this geofiber instead of our iron fibers also. We can use this one. Geomesh mattings are also there. Geopipes actually for transport of these oils or liquids, water and liquids also we can do that one. Another important this beauty is geo bags. Actually, geo bags can be used, but they are recyclable. Normally, you are using gunny bags and jute bags. So, especially for irrigation structures, we use these gunny bags in natural disasters of any breaches are there. But one time only they will be effective, and sometimes it goes off also. Whereas geo bags, we can replace geo bags. These jute bags by geo bags, they are recyclable. Once a permanent restoration is done, these bags can be taken and used elsewhere. So this is a woven, non-woven. Woven means I think sometimes I think to keep it very what I think the thing is not seriousness also. Woven is nothing but మనం మంచాల పట్టీలు అంటాం కదా, పట్టీలు ఓపెన్ చేస్తూ ఉంటాం కదా. This is looks like that woven. So whereas non-woven means there will be fibers of different lengths also. They can be directly used also. That is wovening and non-woven. Even textiles also woven. Textiles will be there. That is the example of this one else. So this is how a geogrid can be manufactured. That is the mission. So this is a product of. I told you that we can sometimes we can use geogrids also, geocomposites also. So a machinery also comes into place, and even testing of this geosynthetics also is available there. So in this connection, it is my pride privilege that the Professor Dr. G. Venkata Apparao garu is the former professor of IIT Delhi. So he was actually helped the erstwhile state of AP and also the present states of AP and this Telangana also in use of geotextiles. And he was a consultant and also he is guiding. So that's why a lot of the economy of structures also was achieved. So actually he introduced, he was very popular with the R&D department of in roads construction and bridge construction also. I was introduced to him a decade back. Then onwards, I started promoting these geotextiles in irrigation department also. So this is Jio Grids. So I told you that any reinforcement of both ways will be there. That we will have a grid like that also. Jio Grids will be in biaxial and uniaxial. Biaxial means it will be with a fixed dimensions of like a square, whereas uniaxial is one-sided. So that is only, it will have effectiveness on one way only. So that is the thing else. So this is GeoNet. I think nothing we have seen that fisherman net and other nets will be there. So even that iron nets are also there. So the one form of this one is GeoNet. So this will also improve the soil stabilization and also improve the foundation, and also sometimes it will separation between two different materials also. We'll use this net. So they are geocomposites. I told you that composite is nothing but a product using 2-3 varieties of geosynthetics. These are all different products are also there. In some important cases where it is required, we will use the geocomposites also. So I told you that biosynthetics, actually this is one coir. I think coir is not a, I think it is a reusable thing. So of course presently we are using for car cushions and also some of the mattresses also, but this is in civil engineering field also you can use coir geotextile, but the coils must be treated against any pests or anything else. So that is also environmental friendly, and also waste disposal also can be reduced. So I told you different functions of geosynthetics will be there. One is separation. So you all know that in road, I think in irrigation also we'll have a homogeneous earth ramps and also composite earth ramps of two different types of the soils. We use it pervious and impervious. So whenever you are using two types of soils for separation, between the separation of the surface, we can use this one. Drainage media. So actually when the soil also, when rain, I think today also the heavy rain is there. So when rains are there, soil is getting saturated. When saturated condition, soil will become less strengthy. So in that case, we will use these geosynthetics so that the moisture that is there in the soil can be drained up through a proper outlet. Filtration, that is also different soils. Soil, I think our foundation or our earth is also different material will be there. We can use this unless we drain off that moisture is there, the strength will not be achieved and it won't last long. Otherwise, settlement also will take place. So filtration media it will have. Reinforcement, I all know that how we are using a steel reinforcement for a slab to give more strength. We can use this geosynthetics as a reinforcement to give strength for that component of material. Moisture barrier, actually, so sometimes different layers of material will be there. Once we saturate, the moisture of one layer should not be transferred to other layer, then we use it as a moisture barrier, and also cushion also. Normally in engineering structures, some black cotton soil is there, we will replace soil by sand to a cushion, to give a cushion for the bearing capacity, improving bearing capacity. Instead of that, we can use this geosynthetics also for the cushion also. So this is separation function. I told you some different soil categories, soft soil and coarse soil is there. So if geotextile is placed, that will separation. Otherwise, what will happen is coarse soil will intrude into soft soil and its characteristics will be changed. So any design parameter for the different soils will be changed. So if we provide a geotextile, automatically there will be a bifurcation between the soils, and they will retain their own strength and other properties also, soil properties. So this is a drainage function. I told you that by putting this geotextile, so it will drain off. I think the previous pores will be there so that the water will be drained out. It will be connected to an outlet. So because now the topic is limited to limited to the irrigation department. Otherwise, multifarious functions are there in other roads and building department, public health, engineering, and sanitation also. It's a filtration media. I told you that natural soil will be there. So with a voids, different types of voids will be there. And also ultimately underground drainage will be there. I think any moist soil, any rain comes, surface drainage will be there and underground drainage will be there. So when you put a geotextile here, the only water will pass through this one. I think there is a engineering requirement is we must see that the soil should not be migrated. So that will help, only water will go without migration of this soil or whatever this material will be available there. So this is reinforcement. I told you that so the Jio Grids of bioaxial is there. If you place that one, that gives strength. That is the reinforcement there in both ways also. So where are it is application for what these are applications are there. So potable water, I think reservoir water and also things to avoid wastage also, you can use the liners. Secondary containment of underground storage tanks. I think apart from overhead storage tanks, there will be underground storage tanks also there. So you can use, normally you are using concrete RCC walls. In place of that one, you can also use this geomembrane also, so that the CPS losses will be there, and also solar ponds and agriculture industry. Now agriculture, we may ask that how it will be help agriculture industry. Normally any wetting will be done, irrigation will be done. So due to hot temperature, the moisture will be slowly evaporated. So normally you can see that in agriculture also they lay the cover the soil, topsoil with this geomembrane, leaving that whatever just required area required for the plant. Aquaculture industry, I think it is also, because agriculture is nothing but your fish ponds will be there. So to retain that water in the fish ponds also, you can use this one. Golf courses, water holes and other sand bunkers also there, you can use it. All types of decorative and artificial ponds also, you can use that one. Water conveyance of canals. I think you all know that most of our irrigation department do canals, if unlined canals, they give a lot of seepage. So now we are using this to minimize that seepage. So now even with a composite with lined canal also below that, we will place this one. The life of this these geosynthetics will be 30 to 40 years also. And also waste conveyance of canals also. Suppose drainage waste is flowing. So otherwise, if that you allow that one without lining, that whatever inferior material and foul material is there, that will penetrate into the adjoining soil land. So by placing this one, that can be also this one else. Primary, secondary, and tertiary solid waste fields. We all know that now there is a depth of land for solid waste management. So now geotextiles is coming into the rescue, and it is economizing the land requirement, and also we can have a high heaps by using this one also. I think in thermal power plant will be ash ponds will be there. Ash ponds will also generate some wastewater. So you can use there also, you can use the geotextile. So to avoid seepage to the adjoining lands. Vertical walls, I think single and double leak detection walls also, I will tell you that one example also there. Now we are using RCC reinforced cement concrete walls, but that is very costly, and this one also it is not environmental friendly. There also you can use this one, replacing the RCC walls. So in earth dams also we are using it. In cutoffs also we are using to seepage control, and also emergency spillways. What is happening is after about a passage of time of 30-40 years, so the dam or spillway is vulnerable leakage. In that case also, I will show you good examples of how that retrofitting will be done using this also. That can be done. Waterproofing lines, even tunnels also, you can use this one as a waterproofing liners. And seepage control of earth. Coffer dam. Coffer dams are temporary dams. You cannot invest large quantum of money. So temporary for 2-3 seasons to build the main dam. So there also seepage will be there. So instead of extending the dam to greater size, so by using this geotextile, we can economize that one also. Floating reservoir also we can use it one, and prevent pollution also, we can prevent pollution. And also transport is, liquids are transported in trucks also, we can use geomembranes also to avoid foul smell and also leakage also, and also the washer liquids also. And barriers, I think I told you that landfills, that waste to solid waste management, if you have a landfills, will have a foul smell. So this will act as a barrier of the avoid the foul smell also, vapors are also there. And this is expansive soils also. I think some of the soils, expansive soils, the construction of that structure is very difficult because we cannot improve this strength, and the design will become uneconomical. Then we can use this geotextile also to improve the expansive soils also. So liners of each speeds, I think like many things else, mostly. So farm barrier tubes as dams also. I think best example is these plastic, what you say, that synthetic dams. So rubber dams, we see that rubber dams are there in Europe also. So I will show you that rubber dams also. They are acting as rubber dams also. Instead of, we can save a lot of soil and lot of concrete also. Water flow, that pipes also through, we can have a geo pipes. And beneath highways, I told you that now it is general application. I am telling you, in highways they are giving a lot of economy and replacement of the existing material, and the containment of structures of some temporary surcharges also. That means if surcharges height is more, that's the retaining wall cost will be more, then we can contain this one also. I think that many applications are there. In soil compressibility also it will improve. What is happening is poor soil is there. If you construct a structure is there, and there will be permanent settlement and temporary settlement. So when you use this one, that compressibility can be reduced. So beneath seepage losses of below ground also there. Like that, many applications are is a flexible form where loss of material can be used, where it can be recyclable, it can be used a number of times, and its life is also more. So this is one example. Actually, river control, erosion control, and sea corrosion control. I think because the irrigation projects, I am telling you that it is subject of irrigation department only. So if you don't have any protection, automatically, so the whatever exiting land will be get eroded. Ultimately, the river encroachment will be there. So in there, we can use this one. I will show you the different pictures also, how we can normally river erosion means slipping up that bund. So by this one, how nursery it was done with using this geotextile, and that land can be used for many purposes, industries, houses, or anything. But ultimately, river control and sea control will be an irrigation project. So that irrigation department will only take up. So this is another important thing is river erosion. I think in Godavari, Krishna also, at the adjoining to the rivers, there will be a lot of habitations will be there. So they erode the banks. Ultimately, it will encroach into habitation. So you can use this geotextiles. There is a common word we use is groyans. Groyans, normally rough stone groyans will use it. But rough stone groyans normally use it in 1 year, automatically that the stone, whatever is there, that will be flow along with the material. So if we use this gabions, they will retain that material, and ultimately it will serve the purpose. It is a repelling groyan means, so ultimately the river bank will be resettled here, this one. Another example is geotube. Here we are using that gabion, whereas this geotube also, instead of this one, geotube also filled with sand, we can put it use as a groyan. So this is another form of this one else. And the purpose of this thing is they are not permanent. At one point of time, after 4 years or 5 years, ultimately the river will deposit the sand, and the material will be get deposited, and ultimately it will arrest that whatever erosions will be there. So this is actually groyans normally use these rough stones. Actually, I told you that sustainability of this development retained by economizing the natural soil. So I think stone is also metal will be there in the soil. It is not renewable. So we can minimize the use of this one by using the geo bags. Inside heart is geo bags, and only cover is only with the stone, so that we can reduce the quantum of this one. Sometimes in coastal area, the quarries will be far away, about 100-200 kilometers. The cost of this will become very enormous. So at that time, we can use this one to economize the structure. This is one is the part of irrigation structure where we can use these groyans not only for this erosion, whatever erosions, and also depositing also some of the irrigation, minor irrigation sources also will put a groyan across the river and divert the water through canal system. So, I think we want to have some construction, but in the amidst of water, you cannot. Soil will will be eroded. Even sand won't retain. Even stones are kept there. Also, they won't retain that shape and size. So then we can use the gabion. Gabion is nothing but a box. We can keep any size of stones in that one, and ultimately they tied with different gabions and ultimately cordon off this one. So normally this is nothing. This is one form of this coffer dam. I can tell you that. Suppose you want to have any construction, we'll form like this one. CPS also will control it. We make this area dry and have construction. Also, you can the erosion. Erosion, it will also purpose the erosion of either sea or the river also. So I told you that even fish ponds or some of the even minor irrigation ponds are also there. So the liner, actually, you see in this membrane is there. That is a leak proof. So by putting this one here, this is the whatever quantum of soil, water will be there that can be retained for a long time, and whenever it will be. Otherwise, if this is not there, in 1 or 2 days itself, the seepage process will be much more. So I told you that is a canal lining also. We are using this geomembrane. You can see this geomembrane fiber. So it will reduce the seepage losses and also transportation losses also. This is one of the applications. In our Nagarsar project also, World Bank project also, we have used this one. I will show you that figure also. This is actually, this drawing was issued by our chief engineer. When I was the chief engineer, Central Design Organization, this drawing was issued using I think this is the lining is here. Below that, we will use this one so that seepage can get reduced, and it will be the loss will be get reduced, and it will be sustainable also. It is a composite application. Along with CC lining, we are using this one. But everywhere you cannot use RCC lining. So in that place, we will only have this geomembrane and also this one else. And a lot of specifications also, things were there. Some of our friends attending this one, they know about this one. So another even not, I told you that these geosynthetics are in use about 5 decades itself. In Europe and other countries, they are doing it. Actually, they are giving the technical knowledge to us. So this is one dam, Valcross Dam is there. So actually this is, any dam will be protected by a rough stone revetment, so that wave speed and wave force will be there. So what the soil will be get eroded. So we use this revetment. Below revetment, we will have a metal filter. So that facilitate the drainage. Any rains comes, the water will flow on this one. So when we are using this one also, it is effective. Otherwise, this is not there. The soil. Yesterday also in one of the WhatsApp group, people say that the lining of Nagarsar left canal is getting settled. So that drainage is not proper. So if you have effective drainage, we can use this one also. So this is how I think a dam in Valcross dam in France. So actually this is a dam is here. So we are putting a geotextile membrane. Over that we are putting a riprap, so that any water, whether it is a river water or rainwater is there, it will be a mechanism of drainage without disturbing this body of this wall. So without any erosions or dips or anything else. So this is another concrete dam also. So this is Lagonio Dam in Italy. So after some time, actually these concrete dams will prone for leakages. I think this dam might have an age of 50 years. So this dam is getting leaked. Then we have used that the project has used this geomembrane, geotextile to paste this on the face of this one, and the seepage was lost. And in India also we did one project. I will also exhibit that one. So this is a dam structure on the front face. This PVC geomembrane and geotextile they placed here. Of course, not that much easy. So we have to fix it with the heating and all those things. Then once this is done, automatically there will be no seepage. So any dam is supposed to retain the reservoir capacity. So if some seepage is there, so it will not serve the purpose of our irrigation or hydropower or anything else. So the retention of water storage is also important. But of course, new dams will fulfill their requirement, but old dams will have seepage. So it may be some problem of I think these wear and tear and other reasons will be also there. So this is ultimately what dam you have seen. It was fixed with this geotextile or geomembrane, geosynthetics. You can see that it was pasted here. In beneath also that will protrude into the keying will be there. Ultimately, by doing this, the dam is retaining its own capacity. This is retrofitting. So then generally what we generally engineers do that when dam is not serving its purpose, we'll go for a new dam. New dam will be capital cost will be very high. So if you have this retrofitting, that will be economical, and the life of dam is also will be get increased. So Kadamparai Dam is one dam is there in the Tamil Nadu. So actually the hydropower dam. It is a pumped storage dam actually for a capacity of 400 megawatts. So its storage is 26.85 million cubic meters. Actually, when I was CEDO also, I have visited this dam to replicate the same in some of our dams are also there. So it is a masonry dam. I think for economy of engineering, we use the local available material. They also use the masonry. Now I think concrete dams are there. Previously masonry dams are there. When our masonry dam is there, they will be joined. So that depends on the skillness of the mason. So actually they built that one. It is a coating of it is a cover of this one Sabal Dam. So actually it was completed in 1984, but actually CPS was observed in when the first impounding itself 1120 liters per minute in surface area. I think it was on. Later it was increased to 995. So ultimately the dam is not retaining any water. So then the retrofitting was taken up and it was done. So this is actually you can see. So this is a masonry dam. The joints will be there. Water is getting leaked to this one else. So ultimately, the purpose of the dam is not serving. So though it was commissioned in '94, till it was repaired in 2005. So the dam has the capital investment has gone waste. So ultimately, so it was retrofitted using this one. So its retrofitting is done by waterproofing liner. I told you that one of the Italy dam that was they fixed that PVC membrane. So similarly here also 2.5 million mm thick that membrane was fixed by heating and also the non-woven variety, and also it was fixed with by nailing also. So such a height of 40-50 meters, simply if you have adhesive and fix it, I think it will peel off. Ultimately, it was fixed with steel rims and also steel battens and also fixed into this one. This is the mechanism. PVC geocomposite that was used. Composite was used here and anchored to the dam surface. And flat profile of steel was also fixed in different at intervals of 5.1 meters, so that whatever fixing of that geomembrane is there, that will be intact. So ultimately, the work was completed in 2005. So this is how it was fixed here in Tamil Nadu itself. In our country also, this is the first of its kind it was done. I will tell you, this is a spillway regulator. This is a masonry dam on either side. So masonry dam is covered with concrete. So sometimes even masonry dam only that with only pointing will be there. So this is the dam. This is a portion of non-overflow dam. This overflow dam is nothing but our spillway regulator. So you can see that this entire thing is fixed with Geosynthetics in Tamil Nadu. Ultimately, it has become very proof of limited CPS only. I will discuss about the cost aspects also. So the work was completed. This Kadamparai hydroelectrical dam in Tamil Nadu, very close to. I think this is one of the place. I think I recollect and tell you that one place is there. This is hydropower dam. So actually, initially after completion of retrofitting, they predicted 1400 liters per minute. This is against the repaired status of 28,000 liters per minute. Now it ultimately, when actually it was measurement out there, it is only 63 liters. That is much low. And I think the cost of this dam that was happened is 12.48 crores. That is for repair. So the surface area is 12,700. That means per square meter, it is costing about 10,000. So they have given a warranty of 10 years also. So ultimately, now the dam is again functioning, and of course, it is a hydropower dam. Whatever investment they have done, they got in within 5 years. Economic rate of return was in 5 years. So this is one of the way of retrofitting using the geosynthetics. Actually, now it is less than 100 liters per minute, which is permissible in any dam as per ISA code or State Central Water Commission. So, and where other applications of this this one is in earth and rockfill dams also use it for water tightness. And I told you that different we use have a the homogeneous section, also the composite sections will be there. In composite section, different soils will use, that is permeable, impermeable soils are there. We can use geomembrane there, and also that provides a drainage media without soil migration. Actually, we will use the sand filters also. Beneath that sand filters also, they put this geomembrane so that only it will the drainage reliable seepage. I think earth dams are not, they are rigid dams, they are flexible dams. Then some seepage is allowed, but some dams they seep more quantity than what is designed. At that time, you can use this one. It is a superior performance and cost effective. So they are also raised. Sometimes old dams also need to rise. So automatically for a concrete dam, you will raise it. But earth dam rising is not that much easy. For example, is our Nizam Sagar also. It was silted up with a lot of siltation, capacity is reduced, then they have raised it. At that time, of course, they have not used geosynthetics, but you can use geosynthetics with lesser cost. I will show you some figures how we can raise a dam, existing dam also, new dam. So or sometimes the FRL, MWL also, because floods will come, more inflows will come, we have to modify the standards also. That modification of standards also, we cannot replace a new dam with higher cost, we can modify with lesser cost using this one else. Also, seepage control in earth dam, you can use geomembranes also. So geosynthetics are further used to prevent soil migration. Actually, the stability of earth dam is also we can allow seepage, but soil, if water, soil flows along with water, ultimately it will be converted into piping and ultimately dam will breach. So this that soil migration it will arrest. So that's one else. So I can show you. So this is one dam where they want to raise after subsequent time, whether to increase the storage capacity or rising the maximum water level and also FRL module. So then they interconnected the membrane, and on the rear side they have raised this dam. This is one media so that there will be no seepage. If it is not there, simply raise it, water will flow in between the new dam and old dam. So another important thing is if seepage is more in the front face cover also we can give it. In our earth dam, my irrigation dams, so we will have a clay blanket in the reservoir itself of 10 times height. So that clay blanket will be only don't last long. We can use this one. It will have 30-40 years capacity. It will reduce this one. So we can have this face this one, and also we can use geomembrane. So we can to face work also fixing at with the toe wall, and also it will be kept into the heart of this dam so that it will fall through. So gabions, I told you that gabions technology is nothing but replacement of our concrete wall or masonry wall also. So normally for masonry dam, we have to put cement mortar between the stones. So whereas so there is dry walls also will be there. So if you put dry walls one over the other, so without any mortar, it will simply they disintegrate and they fall on their own. So in that case, we use this gabion box, fill that bags with stones, and different boxes can be tied each other. What I have shown you in that middle of water, one gabion that wall was there. That is a replacement of concrete wall. This is a concrete walls are actually they generate lot of heat and also carbon dioxide also. For production of cement will be a lot of carbon emission will be there. Even for while construction also carbon emission will be there. If you replace that one with this one else, that is eco-friendly, and it will gabion walls never this one else. Even retaining walls, high retaining walls, we are using the RCC walls are very costly and also they are not environmental friendly. I told you that natural material, that is nature's material, that is unrenewable material will be got exhausted at one point of time. That will arrest the sustainable development will also there. So what is this one else? In the concrete lining also we are using geosynthetics. So such different structures also we are using it. So you can see this one. This is also one sea erosion. You can see some ships are also going there. So there you can use, we are using these gabions of different shape. It may not be a box. It can be a net with this one else. Below that stone is there, because stone is there even, but waves, sea height waves are also hitting it on that soil will not be eroded. So this is one of gabion, coastal protection of this gabion. So that coastal is also, it will be done by irrigation department, mostly protection of this sea erosion also. So this is a box, gabion box. I think these different sheets will be there. The sheets will be fixed with each other, and it will be made into a box. The top is the lid is here. In this one, different side of stones will be kept inside. If the box is not there, the different side of stones are kept. So they will disintegrate, and ultimately they will retain. They will not be retained as a structure, but the gabion will make it retain as a structure. So this is one river bank erosion. So they have used these gabion boxes one over the other. The design will be there. Simply cannot do that one with a design and how much, what is the box size and what type of stones will be there. So it will be designed this one. You are also using geotextile also to avoid this seepage through this one. And in place of the RCC wall, I think stepped walls will be there. It is a stepped gabion. So we ultimately, so this behind this box, we'll use the whatever. That soil will be available there. We will place a membrane to avoid seepage. And if seepage is there without soil migration. So this is one of the, mostly it was done in the northern Brahmaputra river, other rivers, this was done. That is because very costly and every time flashy floods will be there. So water production they are doing. This is an alternative to the failure of this river protection. So this is retaining walls also. I think normally 10 meters retaining wall is there. You want to construct a wall. This is very costly of RCC wall. This one also now it is replaced by a terra mesh. So these are the terra mesh and gabions are also there. Behind this one, the soil, local soil available will be there. And ultimately, is a key trench will be there also there. This actually we have constructed this in one of the in Kurnool and other areas also instead of a wall. I myself have seen given the approved this wall, and this is I think we have saved a lot of cement, concrete, and also carbon footprints also. So this is also possible. So this also continue. You can so these are the gabions. I think minute details are given here. So the design will depend on the foundation soil characteristics, C5 values, and also the unit weight of that one also. We'll design that one. Ultimately, will be box and terra mesh will be there. The details of terra mesh 1000 geotextile, that is the specification of that one. These specifications will be so the code also now the ISA BIS also codes are code also has published codes on this one how to use this one. So this I told you that river tunnels also CPS river tunnels also there CPS will be a lot of CPS will be there. Ultimately sometimes if CPS is more it will collapse also. Now in river tunnels also we can use geomembrane. Over that we will have a concrete lining will be there. So this is actually see during construction these are geomembrane. Over that it will be covered with this one else also. Normally many old tunnels without geomembranes are leaking. So I think old tunnels are there and they are also safety point of also this is required. Normally tunnels will fail because of the heavy seepage and also the proper nailing is not done. So the nailing also this geosynthetics will make a part this one. You can see this one else. So flood mitigation. Now it is very important that floods we cannot contain the floods. We cannot contain the heavy rains. So at that time also we'll have in actual flood mitigation also. Normally during flood time earth bunds will breach, canal bunds will breach, and also some of the gates will be get washed off. Even earth ramps will slip, side slopes will be there, and we have to somehow the protected rough stone will be also cave in, and also slip will be there. And during in the downstream side of our spillway regulator, for example, Srisailam also there is also cavities will be there. So normally these features will occur during this one else. So normally conventionally we will be doing a lot of things with gunny bags and other things. I will discuss that in the next slide. How we can be alternative geotextile will be alternative to the regular thing. So normal floods we use gunny bags. I think that is time tested. I think that is locally available thing. So we use the gunny bags, and even now a shortage of gunny bags also there. We will because when we want to close a breach, so if you soil put it, it will be get diluted. It will be go along with water. So normally you use gunny bags, putting some sand, all the things. But that is one time use, and sometimes even the temporary restoration, not a permanent restoration. So in that place, sometimes even the gunny bags also will be get prone. So now in place of that one, you can use these geo bags that is recyclable. Normally the gunny bags and the protection will be temporary protection, and after that permanent protection will be there. So after permanent protection, all of these investment and whatever you put it go waste. If you use the geo bag, it can be removed after permanent protection, used elsewhere also. And also the stones also, I think any cavity is there, use dump the rough stone also there. I think that rough stone also measurement is a problem. Some of our engineers also land in with vigilance cases also that the quantity what they have recorded is not visible there. The people have also that you have not put in quantity and you have inflated it. But whereas you use this that whatever gabions are there, they are the sizes will be fixed, and we can also they are almost a permanent measure. We can see that one also, and we can department also execution also using, and that can be done. And also when slipping of soils, I told you that earth ram slipping is there. You can use geo bags. So to protect that one, normally you are using gunny bags to temporary protection. We can use geo bags, and for that we can use the gabion mesh also. So even that stone dumping we are doing in flood disasters. So instead of simple stone dumping, we can use the dumping in a case of that gabion, so that it be more effective, and loss and wastage will be also less. So these, I told you that these are all the geo bags. So you can see there can be get filled and kept it here. Instead of a gunny bag, these bags can be used for the flood disasters. they retain, they stand. The life of this bag is also about 25-30 years also. So now in this bag, earlier I told you that soil will not retain, but in these bags, you can, if sand is not available, you can use that one. Nowadays, sand has become very costly, the scarce material. So you can use the local available material soil also in these bags and put it here. And again, once the permanent restoration is done, these bags can be taken and used elsewhere, or they can be used as a permanent protection also. So these some of the things they protected this the geo bags that are used in protection. You can see this layer of bags. I think they are nothing but replacement of your rough stone. So I told you that rough stone quarries will not be there everywhere where we need it. So we have to bring it for 100. For example, in West East Godavari, the quarries are available there in East Godavari, Dhauleswaram. So to do a work in Bhimavaram, they have to bring that about nearly about 100 kilometers. So that is very costly. In that place, we can use this one. And also the soil protection, all those things also you can do this one. So these are also protection, but this is on Lakshmipuram Keri project, Uttar Pradesh. So this was this one. Else geobags, they are very used and they are economical, and they can be used as a permanent protection also. These are some of the, you can see that I told you that even stone pitching also sometimes get disturbed even for earthworms also. You can, if you use that gabions and mesh will be there, it will retain for a long time. Normally, it will also get every year, you have to maintain that one. So you can also see taking the material because in Brahmaputra or some other places, material also taken, the material was taken there. So you have used this revetment with this one else. We can see so geo bags were spread here for river protection. So I told you the geo bags actually. So you can, in disaster management, instead of gunny bags, you can use geo bags, we can use gabions. Also, I will share this. I will leave this presentation in our IEA also. I think I request them in the WhatsApp group also. I myself will post to them. You can also see this one. Geotextiles also, geo wires, earthen bunds, breaches. Normally, so restoration because some irrigation will be there. If a canal bund breaches, so immediately there will be hue and cry from the farmers. So immediately sandbags they use it, but material will not be available. Soil cannot be used. Sand is also costly. Then you can use geo bags using the local material available there. And also, if some covers are there, such as dams or some permanent structures also collapses. So in that case, also you can use instead of dumping stone, you can use gabions. So with proper measurement and proper recording, also you can do that one. And sometimes I told you that the spillway regulators also during heavy flood also 12 will be get eroded. So there also you can use this one else. So ultimately, so the conclusion is that the application of geosynthetics irrigation projects in earth dams you can use, canal structures you can use, canal lining you can use, soil separation you can use. Soil separation means not only in irrigation in roads and buildings, and also some in rural water supply scheme, and also sanitation you can use it as a drainage media. Flood disaster mitigation also I explained to you about geo bags, and also this one is river conservancy works. I think normally rivers are very roaring, so always they cave in and some erosions will be there. You can use this one also. Geo membrane for retrofitting of gravity dams. I told you that not only earth dams, concrete dams also can get protected. So I showed you two examples of Petli Dam and also the Kadamparai Dam also, where the leakage is there. We have fixed the geotextile member to the face of it. With of course, it's not that much simple. It's a lot of technology it can be done. So the use of geosynthetics in irrigation projects is cost effective. I told you sustaining means we can material. I think they are not renewable material of soil, sand and metal is not renewable. We can economize, of course, though we cannot avoid complete thing. We can economize with using geotextiles, the economic design also. They are eco-friendly. So when you are using cement walls and RCC walls, by production of cement, there is a lot of carbon emission will be there. Even during construction also emissions will be there. So pollutions will be there. If you if you use this geotextile, that we can carbon footprints can be saved for construction of sustainable natural resources. Ultimately, now world is counting these carbon emissions, that is climate change, in terms of carbon footprint and reducing the carbon emissions. So we can showcase this using this as a carbon emission. We can claim some carbon footprints also. That is actually we can register so that so much carbon footprints is saved by using this one also. Ultimately, credits will come to the nation's wealth and sustainable development. Everybody discussing about sustainable development. Sustainable development is a part of IES agenda. So these geosynthetics will become part of sustainable development by replacing the the construction material by either by economizing and all the things also you can do that one. I am acknowledging that I told you that G. Venkatappa Rao is a IIT professor. I came into contact with him. I was in Chief Engineer Central Designs Organization. So he has some of the designs I told you that the retaining wall and other things are also there. So he has given to the department. Ultimately, after satisfying ourselves, we have used this one. So that's why I am acknowledging my sincere thanks to him. And also I have taken, there is a professional ethics is there. Whenever you are using some material of others are there, you have to take their permission. So that ethics I have followed today. Today morning, I have taken his permission to display some of the slides what I have done today. So this permission, he was so thorough and gentleman that immediately responded, encouraged me, please go ahead and congratulations. So this is this one else. Now these are the different literature survey. Whenever you are presenting a thing, I think for the engineers also, it should not be. So if you don't give this bibliography, people say that it was adopted from somewhere, also getting that one. So these are the things we have gone through. So sustainable development, the earth, water and air are not a gift from parents, but a loan taken from our children. The development, this meaning of sustainable development, what development then in general terms says that don't exhaust everything of this present generation, leave something to your future generation. Then only it is called sustainable development. Actually, this is what this says, that it is not a gift from your parents, but you have taken a loan from your children. Let us repay it. That repayment is nothing but sustainable development of using technology like this, geosynthetics and other things. Thank you very much. So this is one of the quote of this Buddha, be a light unto thyself. This was one of our colleague and friend, Kondal Rao Garu. So he has shown this one. And ultimately, I thank all of you. I thank the chairman of this Institute of Engineer Telangana State Center, Honorary Secretary, Council, other council members, committee members for giving an opportunity which is close to my heart. I always say to the chairman that let us always prefer a outside speaker. If outside speakers are not available, I will be a troubleshooter and I will always alternate will there, because could not get a speaker there. So 2 days back, my chairman has requested me to give presentation. I thought that R.L. Raju Garu is the Chief Engineer of Irrigation Department. It's quite apt to present a topic on irrigation projects. That's why I have chosen this topic. And thank you very much. Thank you for giving an opportunity. Let us again remember the great services done by R.S. Raju Garu. Thank you very much.
Thank you, sir. Thank you for your kind acknowledgements and also the gratitude to the whoever has helped you in making this one. Really, it's a wonderful talk you have given on geosynthetics and geomembrane and textiles. It's a really new subject which I have really enjoyed in your talk. And now, anybody wants to ask anything? I think
somebody has raised a
hand. Radha Krishna has raised a hand. Sir, any questions, sir? Radha Krishna.
Somebody raised a hand. I think there is time for 5-10 minutes to clear anything. Otherwise, also I think I am very close to all of you. I think my WhatsApp number is there. My email is also there. You can put
Radha Krishna, anything you want to ask?
Happen, sir.
Unfortunately, I joined a little late because I was out of
Sir, I shared the presentation to your WhatsApp, sir.
Yeah. Thank you. Another thing is, I appreciate the way you have presented your slides are so good, and the way you have given is very nice. Only one question I have got. Telangana doesn't have a coast. It doesn't have sea coast. Maybe it's fortunate or unfortunate. So there is no question of erosion of those things. Only in the rivers it is there.
Yes.
But you told mitigation of floodwaters. Backwaters from Polavaram is undaunting this, your Bhadrachalam and other villages, even those are villages which are merged with Andhra Pradesh. They are also getting floods because of the Polavaram.
Yes, sir.
Can you give any solution for that?
Sir, that solution is we have to protect the river banks, that is flood banks. We have to put that to protect that village, sir. In protecting that flood banks also, we can use these geosynthetics effectively, so that water will not flood those habitations, sir. That is the solution available. I think now the Central Water Commission also discussing with the various departments how to do that.
In Telangana, this river and other things, geosynthetics?
Yes, sir. Actually, sir, this is in our dams. Actually, in Kaleshwaram project also, some of the dams are there. So where this G. Venkatappa Rao has given use of this geosynthetics, that was minimized use of sand, other things also, sir. And also it is to safeguard this one also, sir. I will share my PPTs too, sir. It is always,
Thank you
I'm
very
very transparent. Whenever I give a presentation, I will post in the WhatsApp also. Though
Yeah,
that
thank
is
you.
my
I will
way
do
of
that.
sharing.
Do that.
Okay,
Anyway,
sir.
I am not a civil engineer. I am an electronic
But
engineer. Okay.
but is self-explanatory, sir. You can go through that one. Always there.
Okay. Thank you.
Thank you.
It is very good that electronics engineer is interested in knowing civil things. The great thing, no, is we enjoy it, sir. Anybody else, please?
Good evening, sir. ISN Raju garu. Sir, Professor Moinuddin, sir.
Moinuddin garu.
Sir, so very excellent presentation, sir. The slides and all, but the technical, the material which we are manufacturing the bags, that life is 30 years. So in
Yes,
that,
35 years, sir.
35 years.
Yes, sir.
So what type of material we can fill in that, sir? Even mud also, if you are filled, it withstand the water?
Dry mud, not saturated mud. So any dry soil can be filled. Normally in our irrigation department, whenever this breaches comes, we'll use gunny bags with sand. So now because soil will not retain. So now with using the geo bags, soil also available. Dry soil can also filled and keep it there. So one of the things, sir, actually this protection of geo bags is ultimately the structure will stabilize on its own. I told you that that sea erosion, river erosion is there. So we are providing these groyans. So once the groyans are provided, again the bank will restore by its own naturally. So automatically till that time it will retain and it will continue there, sir.
Thank you, sir. Thank you, sir.
Right, right, sir.
Anybody else, please?
Sir, I will share in our group also. If somebody missed it or any doubts are there, I am always open.
Okay.
Open and you can share to my number and also my email also.
Okay. Can you give email and number, sir?
Sir, I will send to your WhatsApp number.
Okay. Thank you.
His number is there in our TSC group and
Okay.
even
Yeah.
committee members group, everywhere it is there.
Okay.
Maybe you can get. There is no problem.
I enjoy
You
sharing
can
all my PPTs to everybody, sir. I enjoy.
Okay. Thank
And
you.
Babu Rao, sir, anything you want to ask, sir?
Sir, Raju garu. So
Sir.
please share your PPT in my, you are sharing in our group or your personal window, sir, please.
In our group, I will share it, sir, so that everybody will get benefited.
Sir, we will forward to you, sir. Babu Rao, sir,
Okay.
we will forward. Whoever now group is there, other group is there, we will put in that group, it will reach you all.
Sir, I will send my PPT to our our chairman. So appropriately, we will forward to the group, sir.
I think it is coming in the YouTube also. IEA is putting in the YouTube ahead.
Yeah, we are placing in the YouTube.
Yeah.
Yes, sir. Thank you, sir.
Thank you.
Okay.
Thank you, sir. Thank you very much. Now, I request our Honorary Secretary Garu, Dr. G. Venkatasubbai Garu, FIA, to kindly propose vote of thanks.
Thank you, sir. Chairman, sir. It is a pleasure for me to propose vote of thanks. Respected Speaker, Dr. I. Satyanarayan Raju, FIE, Council Member of IEI and Chairman RDC Cell of IEI, Engineer Brahmareddy FIE, Chairman IEI Telangana State Center, Dr. K. Sitaram Babu, Professor Moinuddin, Dr. G. Rameswar Rao, Engineer Saripalli Suryanarayana, Engineer M. Srinivas, Professor G. Radhakrishna, past chairman and past honorary secretaries of IEI Telangana State Center, council members of IEI, members of Telangana State Center Committee, corporate members of IEI, distinguished guests, family members of Engineer R.L. Raju, representatives of media, ladies and gentlemen. On behalf of the Telangana State Center of IEI and on my own behalf, I convey our sincere and profound thanks to the Speaker, Dr. I. Satyanarayan Raju, FIE, Council Member and Chairman, R&D Cell of IEI, for delivering an excellent lecture with the topic Applications of Geosynthetics in Irrigation Projects. So once again, I extend my heartfelt thanks to you, sir, Satyanarayan, sir. I also thank the dignitaries, council members of IEI, past chairman, past honorary secretaries of IEA Telangana State Center, members of Telangana State Center Committee, corporate members of IEI, family members of Engineer R.L. Raju, and others who made it convenient. I also thank the representatives of media. Thanks to one and all. Now I request all of you kindly stand for national anthem. Ratnangaru, play national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Jai Hind.
Jai Hind.
Okay, we'll take you.